Yes, the second half of 5 NFB4A does ask students to generalize the procedure for multiplying fractions. But the real question is, how do we move from this idea of reasoning about a fraction of a quantity to finding an exact answer without losing meaning? Because when we lose that meaning, that's when we see issues pop up later in middle school, where students get confused between the procedures for adding, subtracting, multiplying, and dividing fractions.
So let's pick up where we left off in this week's Math Standard Monday video. The algorithm is a shortcut for a unit decision students have already reasoned about. The whole is the distance from 0 to 5 halves. That distance is made up of 5 halves, and we are finding 1/3 of that entire distance. So far, we only know where the value belongs, not its exact size. To name the distance exactly, we need equal sized units that work for the halves in the quantity and the thirds we're using to scale the distance. Right now, halves are too big and thirds alone don't align with halves. So we ask a measurement question. What unit lets us describe this entire distance consistently? We keep the whole the same and refine the units by creating additional thirds. Each half is now partitioned into 3 equal parts. Those parts are the same across the entire distance. That creates a new unit size, sixths. Nothing magical happened. We didn't change the value, we changed the unit. Now, every half is made of 3/6. The entire distance of 5 halves contains 15/6, and 1/3 of the distance is 5/6. The sixths exist because they are the unit that allows us to measure the scaled distance exactly. The reason the multiplication rule works is because it records the unit structure we created. At the end of the day, procedural fluency is the end goal of 5 NFB4A, but it's most powerful when it grows out of reasoning rather than replacing reasoning.